an exploration into Newton's laws of motion. A video created, edited, and narrated by Mr. Binkling. Today we will explore Newton's laws of motion. The law of inertia, Newton's first law. FEMA, Newton's second law. And the law of equal and opposite forces, Newton's third law. In class, you received Unit 12, Newton's Laws of Motion Graphic Organizer. Today, we're going to separate this into 3 separate portions and study each individual law. First up is Newton's first law. Newton's first law is also known as the law of inertia. By definition, it is an object at rest stays at rest, and an object at motion stays in motion with the same velocity in the same direction unless acted upon by an unbalanced force. As you just saw the ice skater continuing to skate across the screen, the same direction with the same velocity. We're going to explore this by using a plastic cup and a washer. To test this experiment, we're going to use a clear plastic cup, an index card, and a washer. We're going to place the washer in the center of the opening of the cup. We're going to hold the cup still and then quickly pull the index card out. And what you saw was the washer fell down into the cup. Let's take a look at this from another angle. Now let's take a closer look at our experiment. We have our cup, our index card, and our washer. We're going to separate this into 2 parts. First part is going to be our cup and our index card, and our second part is going to be our index card and our washer. So if we look at the forces here, we have our index card, we have the force of gravity pointing down towards the bottom of the cup, and then since the index card is placed on top of the card, you have the normal force going up. Those forces are equal, therefore the card doesn't move. Now with the index card and washer, same idea. We have gravity pushing down, and then we have the normal force exerted from the index card onto the washer, with the normal force pointing up in the same amount, therefore it doesn't move. However, if we remove the index card, we just have the washer there, we not only have the force of gravity pushing the washer down, and therefore it would fall to the bottom of the cup. Now we're going to explore Newton's second law of motion. Newton's second law of motion is also known as FEMA. By definition, if a net force is applied to an object, that object will accelerate in the direction of the net force. So we know force of gravity is 9.8 meters per second squared towards the center of the Earth. Therefore, an apple, as in Sir Isaac Newton's apple, will fall down at the rate of 9.8 meters per second squared. The equation is F equals mass times acceleration. For this lab exploration, we're going to be mimicking Galileo's original experimentation. To test Newton's second law, let's use 2 ordinary balls. We have a plastic hollow ball weighing at 2.7 grams. We have a tennis ball weighing in at 38.7 grams. We're going to get them at the same height above our ground, and we're going to release them at the same time to see which one hits the ground first.
Now let's take a closer look at this experiment. So I was holding two balls. We can call this ball 1 and ball 2. They were both the height, we're just going to call x, because they were both at the same height. If we look at the net forces here, we have gravity pulling ball 1 down and gravity pulling ball 2 down at the same rate. And I was applying a tension force that was equal opposite of the force of gravity to keep the balls in position. Then, when I released the balls at the same time, there's ball 1 and ball 2 again, and we have our ground. The only force acting upon both balls was gravity. Therefore, gravity is the same for both balls. They both fell at the same rate, and they both hit the ground at the same time. We'll call time y.
Now we have reached the third and final law of motion. However, now it is your turn. Using our scientific inquiry skills, research and create your own experiment to test Newton's third law of motion. When completed, make sure you upload your video to the